Hi, so this is a little bit of math review because we have talked about this a little bit before with thermochemistry. But if you remember, you can have when the temperature is changing, the amount of heat it takes to change the temperature is Q is equal to mc delta T. Heat is equal to mc delta T. So when the temperature is changing, it's mc delta T. When the temperature is not changing, there's no delta T. It's just ml or whatever if you're using moles, it's latent heat, but we're going to be using grams, which are heats, which are H values. So in physics, we tend to do it per mole and here, or per gram, per particle, whatever. You can use different values here, but it's going to be mass times a constant for that substance. This is when you're changing state, and this is when you're changing temperature. The heat of melting of water is very high, 334 joules per gram. The heat of vaporization of water is even higher, 2,260 joules per gram. The specific heat of water is 4.186 joules per gram, degrees Celsius. And that's for water. For steam and for ice, it's different. Point is, I can take these values and I can figure out how much energy it takes. So here's kind of the same drawing, but in here we see heating ice, then melting ice, then we're heating the water, then we're melting the water, then we're heating the steam. Okay? When the phase is changing, there's no temperature change because all the energy is going into the phase change. The heat of fusion of water, so the amount of energy needed to melt water is 334 joules per gram or kilojoules per kilogram. That happens to be the same as 79.7 calories per gram. So 79.7 calories is the same as 334 joules. Heat of vaporization is very high, 2,260 kilojoules per kilogram or joules per gram. And that's the same as 539 calories per gram. So you can do this in calories or in joules. Point is, it's a lot of energy. So what if I asked a question? What if I wanted to convert 46 grams of ice to water? So let's pretend that ice is already at 0 degrees. What happened there? Okay. Let's say that ice is already at 0 degrees. So all I want to do is convert it to water. Well, I have 46 grams and the heat of melting or fusion of water is 334 joules per gram. So the H times the mass, so mass times the heat is 46 grams times 336 joules per gram would be 15,364 joules or 15.4 kilojoules. So it takes 15.4 kilojoules to melt 46 grams of ice. Let's take that same 46 grams, and what if I'm just changing the temperature of it from 5 to 10 to 15 degrees? Well, that's when I use mc delta T. The mass is still 46 grams. The temperature change is 10 degrees, and the specific heat for water averages at 4.186, or here 4.18. So I multiply those out, and I get 1.9 kilojoules. So if that temperature change was 100 degrees instead of 10 degrees, then it would be 19 kilojoules. So I'm using 15.4 kilojoules to melt, and this will be 46 grams. So 46 grams of ice took 15.4 kilojoules to melt. It took that same amount if I go all the way from 0 to 100. So if I go from 0 to 100, not just 10 degrees, but 100 degrees change, that would be 19 kilojoules if I had the 46 grams. Now what if I just wanted to boil? What if I wanted to boil that 46 grams of water to steam? Well, now I use MH. The H for boiling is 2,260. 2,260 times 46 grams would be 104 kilojoules. So it's 104 kilojoules to boil in that same 46 grams. The point is, it takes a lot of energy to change the nature of water, whether it be temperature or state or what it is. It takes a lot of energy to boil. You know, that's like 20 times the amount of energy it takes to change 100 degrees. But you should be able to do these calculations. So probably going to be a callback to one of these. When you're changing temperature, when you're changing temperature, it's MC delta T. So mass times specific heat times the change in temperature. When you're changing state, it's mass times the heat of whatever. Heat of boiling, heat of melting, whichever one it is. If you want to do all three, you have to add them together. So that's the math review for this. And if you have any questions, let me know. Hope you get a lot out of chapter 16.